Data visualization, what's the point? Scroll through this thing here. So a lot of this is about using spreadsheets. We're going to be using Google Sheets today. There's this talk about correlation. If you remember using graphs and charts, your charts, you got your x-axis and you got your y-axis. Sometimes we call these, this is going to be the independent variable, and this will be called dependent. And we have like two variables, and we're plotting them against each other, right? We might have dot plots, so you might make a line graph, or you might make bar graphs. Now, when you have two pieces of data, we sometimes talk about how much they correlate. We're correlating them, right? We're comparing them against each other. So maybe independent variable is time over temperature, which is what we're going to do today. Or it could be time over money, maybe how much something costs over time. Or, yes, other things like that you can graph. And then we try to correlate those through some kind of chart. We're dealing with water and temperature today. So if I asked you a few questions, let's do our chemistry right here. Water. Let's talk about water. When does it freeze? You might remember this freezes at 0 degrees Celsius. I didn't write that right. So that's when it freezes, and ice will melt at 0 degrees Celsius. We're going to deal with Celsius today. And it boils. Remember, water boils at 100 degrees Celsius. That's when you switch from a liquid to a gas, right? If I'm getting this wrong, let me know. Maybe there's more subtlety to it. So we're going to remember those as we do the activity today. There was an experiment that went on. And this experiment, this lab group wanted to find the freezing point of an unknown substance. So water freezes at 0 degrees Celsius, but we have every liquid doesn't freeze at that. So we have some unknown cleared liquid right here. So here's the experiment. What they have here is, I'm going to summarize this. So you have this big old container here. This is ice water in here. It's basically frozen water, right? It's ice water. And this is one sensor checking the temperature of that ice water. Now, in this little tube here, we have the unknown liquid substance, and we have a second temperature reader right here, temperature sensor right here. So you got the frozen water. This is going to be pretty constant. This is going to be down here at this low temperature. I think it's about 5 degrees Celsius right here, pretty close to freezing, ice water. And then we have this unknown substance. So it starts at room temperature, which they say up here is 23 degrees Celsius. And you're putting that tube in there with the unknown substance, and because it's around, the colder water, osmosis, right? It's gonna get a little colder here. So we're watching that temperature kind of dip down. Now it was stirring that up a little bit, I guess, to kind of get the temperature going, and it kind of dipped a little bit, but now it's kind of leveling out. And if you actually watch the temperature, so it's got these sensors in here. These sensors are getting the temperature. It's going to, it can record twice every second. And over time, it's basically plotting this out. Notice it started high. This is room temperature. Then it went down. It's kind of flattening out. At this spot right here, what temperature is that? I don't know. I can't really tell from the video. And then it flattens out, and at some point it starts to go down. And this ice water is still staying at the same temperature, but the unknown subject's going down. It looks like it's approaching the water's temperature. All right. So that's what's going on with this. Software records multiple trials in the same spreadsheet. I think a neat thing to see was notice it's clear right here. But then all of a sudden, after he stirs it up a little bit, it's actually freezing. That's what's going on there. This is actually freezing. That's what happened. That's why it's kind of solid there right now. And then when it froze, it kind of flattened lined, and then it's going down here. We'll talk about why it does that more later. If you're in chemistry, you might understand that. But that's the idea. So we have two sensors. Now, we're in this project here, we're going to analyze this data. They did 5 trials here, and they messed up in 4 of the trials. And here's the examples of what they did. In one of these trials, they only read for 50 seconds. In one of the trials, they accidentally unplugged one of the sensors in the middle of the trial. but they plugged it back in. And they weren't sure how long it was unplugged. And one, they never even plugged the sensor in. Geez, these people are messing up a lot. In one of the trials, they actually took that test tube out with the unknown subjects for a while and then put it back in for some dumb reason. And then one of the trials, they actually did it right. So they had 5 different trials. Our job right here is we're going to analyze the data in these trials and see what it looks like. So let's begin this. Open up this sheet in Google Doc. I'm going to clear my stuff here. So you see, if you're looking at this sheet, you see there's kind of 4 sets of data or 5 sets of trials. And they got some information about those 5 sets, a lot of numbers here. Now, this tripped me up. This goes 1, 2, 3, 4, 5 in the trials. It doesn't correlate to this. They randomized the order. I didn't get that at first. I kind of spaced out on that part. So it doesn't mean trial 1 was the 50. This trial 1 is not this trial 1. They randomized this. All right. So I should have renamed them differently. But anyways, we're going to try to figure out which trial is which. So let's open this up. I want to make a copy of this file. We can't edit this one directly. This is in view only mode. So we're going to make a copy. Go to File, go to Make a Copy, and you're going to save your own. So I'm going to call this, I'm going to put it in my drive. I just want to organize this for myself. Maybe you just put it wherever. CSP. I'm going to put it in here. I'm doing this during 6 periods, so I'm going to call it 311 and period 6. And I can close that one. And this is my own data. This means I can edit this data now. All right. So let's made a copy of this. Open the file and peek at the raw data. There's a lot of stuff going on here. Can you really find a meaning from this? Probably not. It's really hard to look at data and just read data, this much data from tables and go, I get it. Yes. Maybe you can. But it's kind of hard. Sometimes it's hard to tell a story just by looking at tables, especially when it's a lot of data. So let's try to turn these into charts. So here we're going to do in step 5. We're going to try to make a graph of all the data. So how do we do this? And I'll walk through step 5 here. So in step 5, if I want to select everything, now you can usually click these column headers, A, B, C, D, and so on, and it'll select everything. You can also select the row numbers, right? What if I want to select everything? You can click this box right here, and it'll select everything. Another way of doing this, if you select anywhere, you go Control A. It'll also select everything. Control A, I like doing that instead. But if you don't, click that box, it selects everything. And after it's all clicked, I want you to insert up here and go to Chart. Insert Chart. And what Sheets does is it's going to try to make a chart that it thinks makes sense. So it'll give you this chart. That looks gross. So, okay, nice try, Sheets. But let's change this. First of all, it's trying to do column chart right here. We got this chart editor. Trying to make bars. That ain't going to work. I'm going to switch this. We're going to, from columns, we're going to switch this to smooth line chart. So now you just got these smooth lines. Now you could have done smooth line versus line chart. So smooth line tries to smooth out like the jagged steps. So there we go. Now that looks a little better, but it's still kind of weird. There's a lot of stuff going on here, and we do have some problems. So when you're doing a chart, if we go to setup again, first of all, there's no x-axis at all. It's just every column in here is just being thrown into this data, and they're graphing it. Now, remember we said at the start, there should be like 2 variables. You're kind of one variable on the bottom and one variable on the side. You're independent and dependent, the x and the y. This bottom, I want that bottom to be my time. And I want this to be my temperature, to match the temperature over a time period. When I'm using this series here, think of the series as it's kind of like my y values. I only want to use temperature right here. It's using temperature and time, and it should have a labeled x-axis. Our real problem here is doing this all at once like this, it just doesn't work out. That's too much. So let's delete this. We're going to have to do this one data set at a time. That's going to be a better job. So that was step 5 there. You're seeing, hey, let's do this one at a time. So I deleted that chart. I clicked it. You can hit the delete key. You can hit the triple dots up there. Just use the delete key. All right, we're going to clean up this data. So how do we clean this up right here? How do we visualize this better? Okay, first I want to be able to see the titles. So right in here is the title for every column, but it's kind of like cut off a little bit. So I want you to select row 1 right up here. And then I want you to, we're going to make it wrap. So if you click over here where it's like this text wrapping, I'm going to hit this arrow. I'm going to do it so it does the U-turn thing. This is called wrap. It's going to wrap the text around to a next line and fit it in. Now, obviously you can't see it. You're going to have to grow this. You can stretch this out. You can also just double click when you're between the two lines and it'll try to resize it so everything fits perfectly. So there you go. Now we're all set up. Now, next step. So I can see all those column headers. Great. Determine what the columns in the spreadsheets represent and share the ideas. So if we look at the columns, okay. So this looks like data set 1, data set 2 and 3 and 4 and 5. And notice we have time and we have temperatures. There's like a group of 3. So these are the temperatures, probably each sensor, and then time. I don't really know which one sensors what. My eyeball guessing is this looks like the water close to freezing, and this is the unknown substance. And this is our time in seconds. That's why it's labeled with the S. All right. So now what we want to do is we're going to make a chart. I want to make a chart on the first data set. So I'm going to select columns A through C. So data set 1. And I'm going to do all of step 10 right now. So select columns A through C. You can do it like left click and drag will let you select them all. You can also like click one column and hold down shift. And this will like select everything if you ever want to do that. If you only want to select certain columns, you can hold down control. It's like little shortcuts. But whatever. I'm going to select them all like this. And then I'm going to say insert chart. All right. So this chart, closer. It seems it's got 3 columns. Now, one of the problems is time should not be up here. Time's not one of my y-axis things. It's an x-axis. So I'm going to remove this. I'm going to go to series right here in the chart editor, the 3 dots. Say remove this. And I'm actually going to add that to x-axis. So what you can do, you can just click time right here because that's going to put that column. Notice like now my time, this is labeled by time. And then these are my B and C columns graphed. Project Lead the Way actually tells you, like, if you can't just, if this doesn't work out, you can also click this box right here. You can actually just select the whole data range yourself. And that'll work. I didn't select everything. I think I wouldn't do it that way. If you can't, if it's very easy, just select this time. Boom. Easy. All right. So now that makes more sense. This is each of these, and this is time down here. I do want to label things better. So I'm going to go to Customize and Chart and Axis Titles. So this doesn't make sense to me up here. I'm just going to call this Trial 1. You know what? I'm going to call it Data. We don't know which trial. I hate calling it Trial 1 because we don't know if it's the actual trial run from before. So I'm going to call it Data 1. I'm going to change the rules. Now, that was under Chart Titles. That changed to Data 1. And then I want to change this label down here. This will be the horizontal axis. Horizontal means left and right. So I'm going to call this that's time in seconds. So I'll say, you want to say what it is, and you also want to label the units so people don't realize it's like minutes or days or hours. And then vertical axis, that would be the y-axis here. This is going to be temperature, and I'm going to say in Celsius. There. So I've labeled my graph. I have data 1 set up. Cool. That's step 10. Now, it asks you right here, which of this data where you have the temperature of the unknown sensor go down, then up, then down, which of these trials does it match up here? They say, oh, which of these? Well, I'll leave it up to you to figure out. It's 4. See how you do this. This trial 1 is where they were only 50 seconds long. 2 is where they unplugged the sensor and plugged it in. This is where they unplugged it for the whole time. 4 is when they took it out and temperature went up and then it went back in. So, yeah. All right, we're going to use the same process to create graphs of the rest of these. So here's data set 1. There's probably a shortcut to do this, but I'm just going to do it this way. So I'm going to delete these, add that. We're going to call this vertical axis. I'm going to call it temp, and I'm going to say C. I'm going to shorthand this. Horizontal is going to be time and seconds. Chart title, I'm going to go data 2. Okay. I'll make this a little smaller. Data 1. Data 2. Okay, so we're going to select these now. The chart. Get rid of this. Axis. Customize. Data 3. Horizontal is going to be time and seconds. And vertical is going to be temp in Celsius. All right, I'll make it a little smaller. Let's do the next one. Set for insert chart. And this is going to be time. Remove that. Boom. Vertical is going to be temp in Celsius. Oops. Oh well. Horizontal is going to be time in seconds. And the title is going to be called Data 4. And then I'm going to do Data 5 here. And then, okay, remove that. Add it to time. Customize. Title. Data 5. Vertical axis is going to be temp, C. Horizontal, time in seconds. Okay, cool. So we do this. I'm covering up all the data. That's fine. I just want to be able to see these all at once. So this is the 5 trials. It's in a random order, so don't correlate to the numbers exactly. The question that we ask next is, which one was the good one? If you looked at all these. Because that's what we ask in 13. Which is the one we actually want to keep? So I'm going to pause. I'll let you think about it. All right, so the correct answer is going to be 4 right here. 5 is where the data died right here. So we're going to delete ones that aren't good. 3, it's where you unplugged it for the full time. Nope. Data 2, I only did it for 50 seconds. I want to do it longer. And data 1, this is where I took it out because you see it's going back up and it went back down. It didn't even go as long, so boom. So trial 4 is actually the good one. What I'm going to do is delete everything else. So that's what... Oh, I hit the delete button to delete them. On your keyboard. If you don't want to use the keyboard, if you hit the 3 dots up here after selecting it, you can go delete chart. Okay. Delete chart. I think you can right click it. No, you can't. Delete chart. Now we're also going to delete all the data too as well. So I want to select the non-data set 4 ones. I'm going to select all these columns. I'm going to right click one of these letters and go to delete columns. I'm going to do that also for data 5. So, because I just want to deal with data 4 columns right here. All that work we did, just deleted. Thank you. But whatever, we got our good trial. Now, got the data that we like. Now we're going to actually analyze this data. So we got our good visualization. You could see it would have been hard just eyeballing the chart here, but this, or eyeballing the table. But this chart kind of tells us, okay, we start off at, like, this is the subject room temperature, and it goes down. It kind of flatlines here, and then it goes down again. It might be like, wait a minute. I thought, like, stuff should just match the temperature of the other thing. It should go down, like, as a line or something, like a smooth curve maybe. Why is it doing this flat area right here? And I didn't know that either. So here's Okay, we'll get into that later. But first, before we do this, let's talk about different functions in Google Sheets. So you click in here, you can see the functions list. Now, these are like different tools you can use. And how do you use a function? Let's say I wanted to add up every number, like add those numbers up. Or I wanted to find the average number. I can say equals, and if you type equals, you can do math. So let's say I wanted to add two things up. I can go this column plus, or that cell plus this cell. I can just add them up. Let's do something actually practical. What if I wanted to find the difference in temperature, right? Maybe I'd want to do that for a graph. And what if I want to add another columns? How do you delete columns? Highlight a column like this, right-click the letter, and then say delete column. Yeah, you can or you just right-click anywhere in the column. Like if I right-clicked here, I say delete column. But I want to undo that. Delete column. So the formulas, I can say equals. Now, what if I wanted to say, find the difference between those two? I can say equals, maybe this minus this one. What's really cool, so it'll just do the math, right? Sheets is really neat. It'll if it tries to think what you're trying to do, and it'll suggest, hey, are you trying to do that for everything? We can do that autofill for you. I say, yeah, do it for me. So this will give you the difference if I wanted to add that information. I'm going to delete that column. I don't really want that. So that's something you can do. You can also use other functions. So if you say equal, there's that list of functions. It's a lot of things. The more you do this kind of stuff, the more you'll learn that you're not expected to memorize this. But here's the thing. If you understand if I wanted to find the average of a number, if I start typing average, there's a bunch of different averages. So I can do average, numerical average of values, ignoring the text. Numerical average of values. Okay, so I say average, and I select a bunch of cells and close it off. It's going to average all those cells that I selected. It's kind of neat. They give you some hints about how these work too, and you can always hit learn more. I mean, one thing, how do you know? The more you do stuff in Excel and Sheets, the more you'll get used to these different tools available. If you don't know how to do something, but you want to see if you can, you just need to Google it. A lot of times I've learned things by just Googling it. That's how I learned what VLOOKUP is. You'll probably learn that in this lesson. I've never heard of that before, but you're how do I do this thing? Think if you can do something, look it up. Someone has already explained this somewhere online. So those are the functions. Now, in this case, we're going to talk about the modulo function. So if you remember the modulo function, modulo is the idea of getting the remainder when you divide numbers. So if I have the number, let's say 40, and I divide it up by 15. Actually, I'm going to do the long division way. I took the number 40. 40 divided by 15. How many times does 15 go into 40? Well, that'd be 2 times. 2 times 15 is 30. Then you have a remainder of 10. So sometimes we say 2 remainder 10. This remainder 10 would be our modulo. So in this case, if I took 35 divided by 15, it goes in 2 times. That's going to be 30. Subtract them, you're left with 5. So our remainder is 5. Our modulo is 5. And we typically use this in computer science type things. We used it to try to randomize numbers, I think, in the Python stuff, but to like limit the range of the randomized numbers. In this case, we're going to use it to help us count every 15 seconds. So imagine I wanted to only, I don't want to have every second have a data point here. I want to just have every 15 seconds. So 0, 15, 30, and so on. One thing I could do is just delete everything. But maybe I don't want to delete all those because I don't want to do that permanently. What else could I do? Well, a neat thing about in math, if I said every 15 seconds, that's like taking whatever that number is, dividing it by 15. Every 15 seconds, the modulo will equal 0 because 15 will divide in evenly. So what I can do is do this fancy formula here. Divide every number by 15. If the modulo is 0, the remainder is 0, count that number. So watch how this works. We're going to use that concept to create a filter. So in my spreadsheet, I'm going to select all 3 columns of data. In the menu bar, select data, create a filter. This is step 15. So select all 3 columns, go to data, create a filter. When you do this, you'll have these little arrows appear right here. These arrows let you filter out your information. So let's say I say these times right here. I can say, sometimes, especially if you have names, like you might want to filter out, like I do this in my class. I say, oh, those surveys you fill out, I say, filter out everybody except for period 4. And then you can like hide everyone else. Or filter out everyone except for 12th graders. It's like you can look at data. Let's say I only want to look at times 0, 1, and 2. It's going to only filter out 0, 1, and 2. Right? Okay, select all again. So I want to see everything again. You can also filter by conditions. So if I go by conditions, I want to say filter out. I only want to see when things are greater than, let's say, 10. And then it'll start at 11 and then go up. It'll filter out 0 through 10. Maybe I want to say greater than, let's say I said greater than 100. Now watch when I say greater than 100. Watch this chart here. It goes from like 0 to 100 or something. The chart moved. The chart actually starts at 100 and then goes up now. So when you switch this filter, it's going to filter which data you see. Now the data's not deleted. It's just filtered out. I'll turn off that filter. So instead of like, going through and deleting what I want, I'm just using a filter to hide that information. So now I'm going to create a custom filter to hide but only show every 15 seconds. The way we do this is we do this formula right here. This mod. Don't have to understand it. I'm going to go to this arrow in time. I'm going to say filter by condition. I'm going to scroll to the bottom where it says custom formula is. And then you're going to type equals and then paste that thing. Modulo 15 says only filter when it equals 0. And look what it did. 0, 15, 30, 45, and so on. So it's every 15 seconds. This is something I didn't know how to do this before. Now, what's the neat thing? Look at this chart. This is the chart now. This is the chart if you show everything. They ask you in this lesson, are they the same? Do they look similar? You look at them. Yeah, they're pretty close. They're pretty close. You can actually filter it. It's pretty close. Not exactly the same, but it gets a pretty close idea. So if you ever want to filter by time, there you go. Now, all right. Last thing of this. Phase change diagrams of water. So this is going into our chemistry classes. I totally forgot about this. So when you phase change, when you go from you got solid, liquid, and gas, right? So any material going from solid, liquid to gas. We have these phase changes if they're changing temperatures. When they have that phase change point, there's a point where the temperature will stay at a constant level, like if you're trying to heat things up, until it completes its phase change. So for example, if you're heating water or heating, is it water? I guess we say water, right? So down here at negative 100 degrees, maybe this is it's basically gaseous, like in the gas state. So let's say we cool it down when we get to 0 degrees Celsius. No, wait, that's like frozen solid. That's ice. Thank you. Duh. Okay, so it's really, really cold, right? So we're heating it up. And then we get to 0 degrees Celsius, which is the tipping point between freezing and liquid. So as it's turning to liquid, the temperature is gonna stay flat until it completes its phase change, and then it'll heat up again. And then it gets to the point where it's like boiling water at 100 degrees Celsius. It's gonna be flat again until it's all turned to gas, and then you can heat it up again. And it works the same way if you were cooling. So if you were starting at gaseous water, I don't know, and then you get to this part where it starts going to liquid, and then solid. I didn't know about this. Or I forgot about this. Some of you probably know about this. But there you go. But the important part of this is to understand that if my goal was to figure out when this unknown substance switches to I'm I'm going to take this filter off. I want to know when this unknown substance, I'll put it on, switches to a, from a liquid to a solid, right? When did it freeze? It's going to be around where it's flat. And if you're looking at this, when is it flat? Let's put that filter back in. Filter by condition. If you're looking at this right here, what temperature is it when it's flat? You look over here, you might be like, 16 degrees or so. Looks like about 16 right here. Okay. So let's say 16 degrees. And we can eyeball that chart, and that's what we're kind of saying in, okay, 18 and 19 is like, okay, hold on. 17 says, configure the chart so it responds to filter and sorting changes. And chart editor setup. Okay, so what's cool is we can go to, if we double click this again, we can go aggregate here for some reason. So like, what if I wanted to change how this, if I wanted to change the order, sort from Z to A, I can flip it around. Ooh, cool, I guess, whatever. Oh my gosh, that just messed up things. Okay, a neat thing they didn't tell you. If you want to lock that first column, do this. They don't teach you this in Project Lead the Way. I do. I like that, especially if you have a lot of data. You want to keep the headers. All right, so you can sort. Oh, actually, we don't. So we have to sort this way. That's right. Z to A or A to Z, whatever. If you do aggregate, then it's going to flip. But who cares on that? I don't see why that's important. I never use this. Anyways, I want to figure out, okay, so we said if we eyeballed this, it's about 16 degrees, right? But what is it exactly? And how are we going to tell what it is exactly? We're going to look at what temperature appears, what temperature is it really when it's this flat line? And one way to think about that is what temperature is it when it appears, what a temperature will appear the most? And we could do that through the mode. Remember mode? Mode, we talk mean, median, and mode. Mode is which number appears the most. So we're going to use the mode function. Now it's in the Google Sheets list, how to use mode. But if you don't know, I want to find the mode of these temperatures. So what I'm going to do is I'm just going to go right here. Equals mode. You open parentheses and you just select everything. Or you can select this whole column like this. It tells me 15.9 is the number that appears the most. You might be like, wait a minute. It's only appearing once. How can you say that? Well, this is our filtered view. If I take off this filter, it's still 15.9. So it's still, when I do this mode, is looking through all of column C. Even though I've hidden some of those columns, it's still using those as part of the formulas. So that's one benefit of doing it this way with filters rather than deleting everything. So that's your mode. That tells you 15.9. So my guess was about 16 degrees is when that unknown substance froze. But doing some analysis, these numbers, 15.9 is more precise. And that's what we got through these experiments. Yeah, that's it. I mean, they talk about, oh, you can also use slope functions and average and standard deviation. Don't worry about this. There's a lot of stuff out there. If you ever think about charts, you're like, how do I do this? Google it. Look it up. And get your answers. Unknown. Okay, so experimental variations. Okay, so they mention here, oftentimes your experiments aren't always perfect. You probably get more of this in like your science classes. The unknown substance really had a common freezing point of 16.6 degrees Celsius, even though our results said 15.9. How close your observed data, was that close? Okay, so why does it differ? So consider how close your observed data is commonly accepted melting freezing point. Why was our data difference? I mean, you could say that the substance was left in a much colder environment, for after freezing, the temperature of the substance continued to drop. Oh, okay. I mean, there could have been errors in this. It could have been the preciseness of these sensors. It could have been It could have been the students or whoever's running the experiment messed it up. Uh, who knows? There could be some impurities in the substance itself. Could be something to do with how the temperature's traveling. I mean, it could be the sensors in the beaker that you're trying to put in with the substance. There could be all sorts of things. Maybe if you ran it again, you'd get different results. So that's what's going on there. Answer the conclusion questions.